Welcome to EDU World Space.
Alright, so here we have the problem 23.50. This question we're going to find out each of the following coordination complex as either diamagnetic or paramagnetic. Question A, we have the complex silver, ammonia, NH3, 2, positive. Alright, so in this complex, the oxidation state of ammonia, NH3, is equal to 0. So if we assume that the oxidation state for silver equal to X, and we know the total oxidation is +1, we'll have the following equation: X plus 2 times 0 equal to +1. So we get the number X equal to +1, and that is the oxidation state of silver. So therefore, the oxidation state of silver is +1, and we know the atomic number of silver metal is equal to 47. So the electronic configuration for silver is Kr 4d10 5s1. So that is the electronic configuration. So if we want to draw the electronic arrangement, or the outermost electronic arrangement, it will look like this. We have the 4d orbital, 1, 2, 3, 4, 5. 5s orbital, 5p orbital. Alright, so there are 10 electrons in 4d orbital. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and 1 electrons in 5s orbital. So that is the outermost electron arrangement for silver. However, in the complex, the silver has an oxidation of +1, so it loses one of its outermost electron and leaves 5s orbital empty with 4d 10 orbitals, 10 electrons. So this electron has been removed. Alright, so the ligand ammonia, each ammonia will have 1 pair of electrons. Since we have 2 ammonias, so 2 pair of electrons are donated by the ligands to the center metal, that is the silver. So 2 pairs of electrons are added to the orbitals, 1 pair and 2 pairs. Alright, so this is the outermost orbital look like for the complex. And if we look at the electrons, all of the electrons are paired up. So no unpaired electrons. So the complex would be diamagnetic. Alright, so this is the part A. Now if we look to part B, we have a complex of copper, Cu, ammonia, 4 ammonia, 2 plus. Alright, once again, the oxidation state of ammonia, we know it's 0, and we assume the oxidation state for copper will be X. The total oxidation state for this complex is 2 plus. So we can have the following equation as X plus 0 times 4 equal to 2. And we get the value X equal to +2. Alright, so this +2 is the oxidation state of copper in the complex. And we know the atomic number of copper equal to 29. So the electronic configuration of copper will be 18, 3d10, 4s1. So that is the electronic configuration for copper. And if we draw the outermost electronic arrangement, we have 3d orbital, 4s orbital, 4p orbital, Alright, so there are 10 electrons in 3D. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1 electrons in 4s orbital. So since the oxidation state of copper in the complex is 2+, so the electronic configuration will leave it 3d9 because it loses 2 of the outermost electrons. So 2 electrons has been erased, 1 from 4s orbital and 1 electrons from 3d orbital. Right, so now we have the ligand ammonia right here. Each ammonia gives 1 pair of electrons donated to the center atom, and we have 4 pairs of electrons donated from the ligand's ammonia to the center atom copper. And since ammonia is a strong ligand, so it will enter into the innermost orbital of the metal. So the 4 pairs will go here, 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 and here. So this electrons has been moved out to a higher level. So we have 1 pair here, 2 pairs, 3 pair of electrons, and 4 pair of electrons. So these electrons will be moved to a new orbital, that is the 4d orbital. Right, so this is the 4d orbital, and these electrons will be moved to here, and this will be gone. All right, so this is how the complex looks like, and this is right here. Is a dsp2 hybridization. All right, so looking at electrons in the complex, we have here 1 unpaired electron. Since there is unpaired electrons in the complex, this will be paramagnetic. All right, so the answer for part B is paramagnetic. Now we move to part C. Part C, we have the complex rubidium bipyridine 3, 2+. All right, so the oxidation state for bipyridine molecule is equal to 0. And the oxidation state of rubidium is X, and we have the total oxidation state equal to 2. So we have X plus 3 times 0 equal to 2. So we get X number equal to positive 2. So the oxidation state of rubidium in the complex is positive 2. Now we find the atomic number for rubidium equal to 44. So the electronic configuration for the rubidium will be 36, 47, 5s1. All right, so if we draw the outermost electronic arrangement for d orbital, 1, 2, 3, 4, 5. 5s orbital right here. 5p orbital. All right, so 7 electrons in d orbital. 1, 2, 3, 4, 5, 6, 7, and 1 electron in s orbital. Since the oxidation state of rubidium in a complex is positive 2, so after it loses 2 outermost electrons, it will leave the electron configuration as 4d6 and no electrons in 5s orbital. So this electron is removed and one of the paired up electrons is removed. All right, so now we look at the ligand bipyridine. So each one bipyridine has 2 nitrogen donor atoms, and 2 donor atoms will have 2 pair of electrons donated to the center atom. So 3 bipyridine will have 6 pair of electrons in total donated to the center metal, rubidium. All right, so since the bipyridine is a strong ligand, it will force the metal electrons to pair up against the Hund's rule. Therefore, the electron pairs donated by the ligand to the orbitals will be, because these 2 will then become paired up. So after it's been paired up, the electrons will move to here and here. And now 6 pairs of electrons will enter 1 pair, 2 pair, 3, 4, 5, and 6 pairs of electrons. All right, so this is how it looks like of the complex. So now we see that all electrons are paired up. So no lone pair of electrons. So the complex will be diamagnetic. So that is the answer for part C. We have last one, part D. The complex is cobalt Cl4 2 minus. All right, the oxidation state for chloride is -1. And if we consider the oxidation state of cobalt equal to X, the total is equal to -2. So we have X plus 4 times -1 equal to -2. So X minus 4 equal to -2. We get the value of X equal to +2. So the oxidation state of cobalt in this complex will be +2. Now we find the atomic number of cobalt equal to 27. So the electronic configuration of cobalt will be 18, 3d7, 4s2. If we draw the outermost electronic arrangement, we have 3d, 1, 2, 3, 4, 5, 4s orbital, 4p orbital. All right, so 7 electrons in d orbital. 1, 2, 3, 4, 5, 6, 7, and 2 electrons in 4s orbital. All right, so cobalt 2 plus, it will loses 2 of the outermost electrons and leave the electron configuration as 1837. So these 2 electrons has been moved up. All right, so now we look at the ligand, chloride. So each chloride atom will contribute 1 pair of electrons donated to the center metal, that is cobalt. Since we have 4 in total, so we have 4 pairs of electrons donated from the ligand chloride to the center atom. And since chloride ligand is a comparably weak ligand, so it will not pair up against the Hund's rule. So therefore, the 4 pairs of electrons will stay in 4s orbital and 4p orbital. So this is how the complex looks like. And now we see there are 3 unpaired electrons in the complex. Because there are unpaired electrons, the complex will be paramagnetic. Because chloride is a weak ligand. All right, so that concludes our part D.